Here it is, our new PowerWall. Well guys, you know what's in the boxes, right? Maybe not so much. Okay, tonight we want to unpack all these boxes here and I want to show you what I actually got. But first of all, welcome back to the Off-Grid Garage here. It is a late night show. It is not sunny hot anymore. It is actually pretty cool. Got like only 22, 23 degrees tonight. Well, definitely ideal to do some physical labor. I actually had a sneak peek in one of these boxes already. And I'm not quite sure if I like what I saw. I want to show you that. I want to discuss it with you and ask you for advice. As always. Okay, that's enough with this nonsense. So, what do we have here? 2 rows, 16 cells each, 2 batteries, 48 volt, around 15 kilowatt each. And these are the cells which will go into our battery shelf here. One at the bottom and one at the top. Okay, so what do we have? So we've got the EVE LF304 and we've got the EVE LF280K. This is the brand new K variant. Well, that really sounds like a virus now, right? But this is the EVE LF280K. So apparently this one has 6,000 plus cycles, while this one has around 3,500, 4,000 cycles here as usually. We want to have a look at the dimensions first, because I think they have changed the complete design of these battery cells now. They are exactly the same case. It's the same depth and the same height. Everything looks exactly the same. 304, 280. And let me get one of these older cells of the 304 I have here. And this is the EVE LF304 as well. But have a look at the design. I know it is the same case. Maybe they are larger than the 280s now. Damn it, I haven't got a 280. Oh yeah, they are a bit higher. See, this is the LF280K, the new one. It is a bit higher than the old LF280 we have. Ah, that's interesting. Yeah, and what you can see here as well, they have moved the terminals further to the outside of the actual battery cell. For what reason? We don't know. Maybe because the newer ones, they don't bulge anymore as much as these ones, because the electrodes are actually further to the corner here and the whole battery is more stable around the corners. But this is just a guess. So this is the brand new one, and it is bulging a little bit where the electrodes actually are, where the terminals are inside. And to be honest, this was always the case when I bought batteries. Yeah, this one is a bit more, but this is the old one. And here the electrodes are far more in the middle than over here. So they are around 22 millimeters away from the corner, while these ones here are about 40 millimeters away from the corner. So maybe it has something to do with that, I don't know. And another big difference, of course, are the terminals themselves, because we have here welded studs, while these ones are the old ones with the set screws. And this is exactly what I'm not sure if I like this or not. This is a ring terminal here, and we've got full contact area here for this ring terminal. If I put the same one on this welded stud here, have a look at this. This is the contact area down there. This is only half or maybe even less. Oh, I need to get the other camera, hang on. Okay, so here we can see the difference between the old battery style, terminal style, and the new one with a welded stud here. and this one has a fairly large contact area, while this one is just the top part which has actually contact to your bus bar, and the bottom part here is not accessible. And also I found this is just a magnet from a hard drive. There's nothing here, and look at this. This one is not stainless, it is steel. I guess it is necessary because they weld this onto the aluminium, otherwise they wouldn't have a chance. So we can see down here, this is actually the flat original aluminium terminal of the cell. And then they have somehow welded this big washer here on top of it. And this is the actual stud with the contact area we are getting now. I don't really know, and it's not easy to scratch. I mean, you can if you use a lot of force with a screwdriver. I can put some scratches on there. Yeah, so this is how it looks like. And as always, the battery cells come with the standard tinned aluminium bus bars. Nice, clean and shiny. And we've got stainless steel M6 flange nuts as well, as always. And actually this time I will use these bus bars here, just in contrast to the aluminium bus bars we have installed here in battery number 2. So yeah, at least if you take a normal ring lock or something, you get maximum contact area to the terminal. But if you use the standard bus bar or the aluminium bus bar here with a slot in it, well, then you are in trouble. And I cannot imagine that you can push 200 amps or even 250 amps through such a small contact area. Okay guys, so let me know what you think about this welded stud situation here with the new cells. At the moment I'm not happy, but I think this is the new standard. They are not making these ones anymore, they are all welded. See, here we've got a nice large contact area, but this is maybe 1/4. Well, we can actually measure it and calculate how much contact area we have left with this new version here. If I do the quick maths here, with this measurement, we've got 201 square millimeter for the old terminal and only 78 square millimeter for the new terminal area. So this would mean we're losing about 60% contact area with the welded stud method. Is that correct? I mean, that would be insane, right? I mean, looking from the top, it is a tiny area what we have, a very tiny area. Okay guys, I want to hear from you about this. Who has got these new cells with the welded studs on it? And have you encountered any problems with heating up bus bars, heating up terminals, candles in the battery cells? Or is this something we don't need to be concerned about? I am concerned at the moment, to be honest. Okay guys, I'm just doing the maths again here. So 16 millimeters diameter we have from the old terminal, and this makes 201.06 square millimeter area. And the new battery cells, they've got only 10 millimeters, which is then 78.54. So it is true, we are losing 60% of the contact area with the new cells, which have the studs welded on to the terminals. Wow. Okay, I'm not sure if this is good. I have contacted Qishou and asked them what the recommended torque for these welded studs actually are. All the specifications you can find online, they are all for cells without welded studs. So the normal terminals and the set screws you put in, and then you've got your 8 Newton meter maximum torque when the actual terminal will start twisting inside the battery cell here. But nothing to find for the welded stud version. I've also sent them photos and asked them for advice because of the contact area, and if this is a concern actually if we push 160 amps here, which we have done before while we were testing, which we have done before when testing all these different bus bars with the 4S battery. And I pushed 160 amps through these terminals here, but if I would do the same, Well, there would be a test, right? I should set up a test. 4 of these batteries here fully charged, and then we push 160 amps through these terminals here and see what's actually going to happen, if they heat up or not. Look at this. It is only this tiny top part of the terminal which actually makes contact with your ring lock here. Honestly, guys, I don't like this. I just texted Amy from Qishou Technology in China, and she replied, "Hi Andy, the torque is 8, 160 amps, no problem." I sent her the photo with the 2 terminals here and said, well, I'm a bit concerned about the small area these terminals have now with the welded studs. And well, that's her reply. No problem, 8 Newton meters, which is a lot. But yeah, I can see we can actually apply more torque to these ones here. They are far more sturdy than the old. That's not the old one. So guys, what I have done now is I have connected 4 of the new 304 ampere hour batteries here in series, connected our DALI BMS, and this is all sitting on the solar charge controller now with 500 watts of solar here in my driveway, and we charge this up tomorrow as much as possible. The batteries are at 3.3 volts, so there could be everything between 40 and 70%. I don't know how full they are. Well, the BMS will take care of it, and of course I've programmed the solar charge controller as well accordingly. So we charge this one up tomorrow, and then we do a 160 amp discharge test tomorrow night when I come back. I actually want to see if these new terminals are heating up. So that's what we are going to do tomorrow. See you tomorrow then. Bye. And for this high power bus bar terminal test, I want to use the original bus bars which come with the battery cells. How nice and shiny they are. So here we can see 2 of our terminals with welded studs, and when I put the bus bar onto these 2 terminals, we can see we have a little bit of gap here, and this is actually the gap I'm using to spread my cells apart, like this basically. I always have a little bit of air gap in between the cells. I'm not a compress guy. Why not? Well, I will talk about this in a different video, but for this purpose we are pushing them against each other, so we can actually now it has problems to focus, but well, it's good enough for what I want to show you. See, this is the movement we can have with the bus bar on the terminal, right? So I'll take the bus bar off for a moment. I want to show you here the actual contact area goes from this corner to the stud, and from this corner here to the stud. So it's just these few millimeters on the top ring of this welded terminal. And if I push it all the way this way, you can already see the gap here. There's no contact area anymore. And the same if I would push it the other way, you can see the gap coming up there. This is how small this ring down here is. So I'm trying now to actually middle this one out, and probably we don't have any. Now see, there's the gap, and if I middle this one out, I won't have any contact area here, and I won't have any contact area on the other side. So the only contact between this bus bar and the terminal is down here, little radius, and up here. This is where the bus bar touches the terminal now. And remember, these cells are rated for 1C discharge maximum, so I can push 300 amps through these cells. And we are using the flange nuts as well, which come with the bus bar. And I'll probably do one first. I'm not really a big fan of these flange nuts because they make really ugly marks on the bus bars. Because of this flange here, it really bites into the material, scratches it, and removes the tin. Just want to check again here. Yeah, we are right in the middle. And then she said something about 8 Newton meters. But I think this is the maximum torque the actual terminal can withstand. before it starts twisting inside the cell. Now this reflection does make a really bad picture here. So I will go with our, or my standard, it's not our, it's my standard 4 Newton meters of torque. Okay. Okay, let me set up all the other bus bars here as well and connect the inverter, and then we charge the vehicle from this battery and see how much amp we can actually pull and what the result is. Are we getting candles in here because we've got very small contact area only, or is this all right? So guys, now I've got already another problem. The ring terminals of the inverter are M8 and I've got only this tiny area. Hang on, I'll get the camera like this. And look at this. This would not make a really good contact here. In fact, it's almost... yeah, that's not good. I need to build an adapter first from M6 to M8. Probably I can... Thanks, Maddie. Yeah, that's better. All right, here's the setup. So we've got our 4S battery here. We have 3 bus bars basically connecting this 4S configuration. And I was going to put some electrical tape on top of these bus bars due to the reflection then with the infrared camera. But it is not about the bus bars this time. It is about the connection we have at the terminals. And if they heat up, we will see the candles coming up here again in these locations here. I have torqued all the screws with 4 Newton meters, even the flexible bus bars here. We've got a 400 amp fuse, bolt-on fuse in between here to the inverter. Yeah, this is all ready to go. I've got my MEN link here for the Tesla charging installed. Inverter is on. We just need to wake up the car. Stop charging. Before we start charging, we want to have a look with the infrared camera how it looks like without any load. Okay, so here we have our 4S battery now through the infrared camera. And you can see this is the hot spot here, 25 degrees. You can see my finger here, 31 degrees. It changes the color. So don't get fooled by the colors here. It is not like the bus bars are already hot. This is just a reflection we get on top of the bus bars from the window actually. Okay, so we are charging now with 8 amps into the vehicle. And from the previous test, this should be like around 160 amps going through these cables here. Just want to quickly confirm this. Yep, 160 amps going through the whole system now. And I'll do the finger test first here and see what's going on. Nothing at the moment. Nothing here. Just checking if there's an immediate hotspot somewhere. But there's not. Okay, leave it charging for a while and we will see how we go. We've got candles. Actually not. If you see the full picture, you can see the bus bars are actually staying cool. Let me see if I can get only the battery without these heating up. These cables are heating up a lot. We know the positive terminals here, the cables to the inverter, they have a crimping issue somewhere, which I cannot really find. And hence these cables are heating up a lot. You can see the heat traveling here through the fuse into the flexible bus bar. But then it goes away actually here, and the terminals themselves of the batteries are staying cool. So let's see if I can get a picture without these hot terminals there. Yeah, we've got 29 degrees here on the terminal after 19 minutes. So 20 minutes charging with 160 amps. And there's no heating up, nothing. Actually, the bus bars are... they're actually cold like cucumber. Apparently cucumbers are a measurement of heat now, so we keep it. They are cold like cucumbers. This one is a bit warmer, a tiny bit warmer. And you can see 31. 31 is the terminal, 32. And the cell next to it is, there we go, 31 as well. So there's no heating up. That is amazing. I would not have expected this at all. I was thinking we've got a huge terminal issue now here with these small contact areas, but look at this, 160 amps, totally fine. Should I push some more amps through this one here? I can connect the adjustable power supply and charge the big battery from this one here just for a moment, for a few minutes, and see if we can get close to, I don't know, 250 amps or so. That would be fun. Okay, so I've now connected the adjustable power supply here as well with 56 volts and 10 amps to our bus bar. So we are charging this power into the big battery. And this time I have connected it directly to the inverter. So let's turn this one on as well. There's another 500 watts. And let's measure the current here. Oh, it's over 200 amps. All right, it's over 200 amps. Okay, let's turn this down a bit. 5 amps. Then we are at 196 amps. Just go a tiny bit higher. 1 amp higher. 200 amps. We are pushing. Very close to 200 amps. All right, yeah, let's leave this running for a few minutes. And then we have another look with the infrared camera if there's any difference between 160 and 200 amps. Wow. So this is the difference between 160, this is like 40 amps. So 6 amps are 40 amps. If I go another 6 amps, we will have another 40 amps. So we'll have 240 amps going through. This is 0.8 C or something. And the maximum the inverter can do then. Okay, let's see. Let's go to 10. Let's go to 10. All right, let's go to 10. Yeah, what we can measure is we can measure them single. 120 here and 100 here. So that's 220 amps now. This is close to the maximum the inverter can do. Wow. 127 plus 103. 230 amps, I think it is. Okay, this is the battery, how it looks like at 230 amps. Can have a look at the terminals here. 33 degrees. But here again, inside the garage, we already have 25 degrees on the workbench. So this is our air temperature, 25, and the bus bars and the terminals are 33, 34 at 230 amps. And Maddie, look at your cables here at 230 amps. They are amazing. They are not heating up. This is coming, this hotspot here is solely coming from the cables going to the inverter and the bad crimp. And here's the negative one. 230 amps. Oh yeah, they're getting warm. Alright guys, let's do the cucumber test. Oh yes, they're getting warm. Can feel it, can still touch it. They're probably like 38, 39 degrees I would say, close to 40. But this is a very extreme test. Batteries are not heating up at all. Cannot feel anything here. Here on the top, they're all staying cold. Okay, let's turn off the charging here. Let's ease off the load. And I'll stop vehicle charging as well. Just want to quickly show you the battery, the terminal voltages across the whole battery bank at 230 amps now. This is battery cell number 1, 3.13, 3.12, 3.12, 3.12. Fantastic. Wow guys, what a test, huh? 230 amps for 10 minutes and no problem at all with these welded studs they put on the terminals now of these batteries here. I was really concerned that we have such a tiny contact area now here, but as you have seen from this test here, it does not matter. It does not make a difference. We are using the original bus bars here, coming with the cells, and torque these down with 4 Newton meters onto these tiny areas of the terminals. and there's no heating up, there's no candle effect we have seen with the aluminum bus bars before, with far less current going through. You know, this was only 60-70 amps and now 230. I mean, the whole system was running for half an hour on 160 amps, charging the vehicle, and then I added the adjustable power supply with another 1 kilowatt on top of it, so we came close to the maximum rated capacity of the inverter here. And no candle effect, no heating up, no hotspots, nothing. Even Maddie's 4-gauge wires here, well, they got warm, but these ones here, I tell you, got a lot hotter. These were like flexible, you know, like the silicon cables. They are super flexible, but this was only because they were heating up so much. They're usually not that flexible here. So if you use these ring lugs here and make your own bus bars, or if you use the bus bars which are coming with the cells, it is all good. Everything works just fine. There's no trouble at all. There you go. This is in rare contrast to the other video we made about all these different bus bars. And I told you it is all about the contact resistance between terminal and bus bar. Apparently this is pretty good here with these welded studs. I'm maximum impressed. And I was super concerned because Qishou told me they doing welded studs now with the 304 battery cells. And I was really surprised to see the LF280K cells coming with welded studs as well. So there you go. Obviously this is the new standard now, welded studs. And 230 amps, not a problem with these. Man, I tell you, I'm so glad, I'm so lucky. I have all these test equipment here and I can do these tests. So again here, these cells from Qishou with the welded studs get my full recommendation. We will do a full quality check in the next video then. There was just me unboxing it and being shocked, seeing all these welded studs here on all the cells with a tiny contact area. But it is all good. Alright guys, as always, thank you so much for watching. Thanks for all your great support here on the channel, all your hundreds of comments. I'm about 1,000 comments back to go through. I will do it this week, I promise. And of course a big thank you to all these wonderful people who have donated money to buy me beer and supporting the channel as well financially here. Thank you very much for that. Also a big thank you to everyone else leaving comments under my videos, using my affiliate links on my website and under my videos, and making these tests possible. And until the next video guys, as always, you stay charged, stay maximum charged, stay safe, maximum safe as well of course. And thank you again for watching. See you then, bye bye. Oh, I cannot believe we pushed 230 amps here.